When you're trying to establish a trig identity that has two fractions in it, often a good idea is to find a least common denominator and add those two fractions together. So that's in fact what we're going to do in this example. So this side of the trig equation or trig identity is going to be the goal. I'm not going to mess with that side. I'm going to try to rearrange the other side to end up with that. So I'm not going to mess with the 2 over sine of u. So let's go and try to find our LCD and add these fractions together. If you need help with this, I've got a few good videos back in my Algebra 2 notes if you want to try to find those. My LCD is going to be made up of the different pieces I see in the denominators that I'm trying to add together. So in this case, I'm going to need both of those pieces. I'm going to need the sine of u and the cosine of u. So sine u times the cosine of u is going to be my least common denominator. And so the way this works then is I have to turn each of these denominators into that least common denominator. So for example, the first fraction already has the sine piece, but it's going to be need to be multiplied by the cosine piece, and the top and bottom will be multiplied by the same thing. And notice I put parentheses around the numerator to remind myself that I need to distribute. For my second fraction, it's already got the cosine of u piece, but it needs the sine of u piece. So again, I'll use parentheses to remind myself that everything in the numerator needs to be multiplied by the sine of u, and I'll do the same thing to the top and bottom. So let's go ahead and multiply this out and see what happens, and this problem is going to get messier before it gets nicer, so fair warning. For the numerator, I'll try to color coordinate this a little bit for you. For the numerator, when I distribute cosine, I've got cosine of u, since cosine times 1 is just itself, plus a sine u, cosine u, those pieces would be multiplied together. I'm going to switch colors to green now to talk about that second multiplication. So when I distribute sine of u to that second parentheses, I will have plus a sine of u times a cotangent of u, and then finally a negative sine u cosine u. And those pieces like the sine u, cosine u, those could be in either order since they're just being multiplied together. All of that big mess, the whole thing, is over my common denominator. I'm going to add those two fractions together, and that common denominator stays the same, which is just sine of u times cosine of u. Okay, so as I told you, this problem is going to get messier before it starts getting nicer and getting down to that answer, my goal up there. Alright, so let's take a look and see what I can do. In the numerator, you probably have noticed that I have a positive sine u, cosine u, and a negative sine u, cosine u. So those pieces can just be canceled out right away. Even if you wrote them down in a different order, a positive and a negative, those are just opposite terms, they'll cancel out right away. Okay, the next piece I kind of want to take a look at, and maybe I'm going to just do a side note for this one, is I just want to look at this term right here, this sine of u times the cotangent of u. Rather than rewrite the whole problem, let me just go off to the side to take a look at this piece. If you've watched our earlier videos, you saw that one of our tricks is often to write things in terms of sine and cosine. And so let me rewrite cotangent as just cosine over sine. And seeing it written like that, you may realize, hey, those sines will just cancel out. So sure enough, they will. Let's get rid of those sines, and all that's left for that piece is just a cosine of u. So actually, then I can make this problem look way simpler, I suppose. I'll replace this with cosine of u. We just figured that part out. So in the numerator, I've got a cosine of u plus another cosine of u, which means altogether, I've got 2 cosine of u's. Just like if you had x plus x, you'd have 2x. So cosine plus cosine is 2 cosine. And then in the denominator, I still have that sine of u times sine of u times the cosine of u. Okay, everything's being multiplied, so things are free to be canceled out if you have any common factors. And in fact, I do. I've got a cosine over a cosine, and well, just like that, we're now suddenly at our identity that we're trying to prove. So I end up with just a 2 over a sine of u, which is where I wanted to end up. So I got to my goal. I've established that identity by adding some fractions together.